Hi everyone and welcome back to my channel Criminology and Forensic Science. Today we are going to discuss an extremely important topic from Unit 1 of Forensic Science, that is forensic investigation of unnatural deaths. Now when we hear the words unnatural death, many of us immediately think of familiar examples such as suicide, homicide, accidents, poisoning, hanging or drowning. But forensic investigation goes much deeper than simply identifying the apparent manner of death. The real question is not merely how did this person die? The forensic investigator must ask a series of interconnected questions. What exactly happened? Where did it happen? When did it happen? Was the body found at the actual location of death? Was the death accidental, suicidal, homicidal, or undetermined? And most importantly, what physical evidence can support or challenge the initial story? Just imagine a person found dead inside a locked apartment. There is no obvious injury, no weapon lying nearby, and the room appears completely undisturbed. At first glance, the death might appear natural, but investigators noticed that a smartwatch stopped recording movement several hours before the estimated time of death. The victim's phone contains an interrupted voice recording, and a glass on the kitchen counter contains biological material that does not belong to the deceased. None of these findings by themselves tell us the complete story, but forensic science is about connecting these apparently unrelated pieces of information. This is what makes the forensic investigation of unnatural deaths so fascinating. The body is not simply examined as a medical object, it becomes one part of a much larger evidentiary picture involving the scene, the body, objects, biological material, digital information, toxicological findings, witness accounts, and investigative reconstruction. So, in this lecture, we will understand what constitutes an unnatural death, why forensic investigation is essential, how different forms of evidence are examined, and how the entire investigative process moves from the discovery of a death to the reconstruction of what actually happened. Let's begin with the basic concept, that is unnatural death. An unnatural death is generally a death resulting from an external cause rather than a disease or an internal pathological process. In forensic practice, unnatural deaths commonly include deaths resulting from accidents, suicides, homicides, poisoning, environmental causes, occupational incidents, and other external circumstances. However, an important point for UGC NET preparation is that forensic classification of death and legal determination of responsibility are not exactly the same thing. Forensic investigators generally work towards determining the cause, mechanism, and manner of death. The cause of death refers to the disease, injury, or circumstance that directly produces death. For example, a penetrating injury to a vital organ may be the cause of death. The mechanism of death refers to the physiological or biochemical process through which the cause produces death. For example, severe blood loss leading to hypovolemic shock can be a mechanism. The manner of death refers broadly to the circumstances in which the death occurs, such as natural, accidental, suicidal, homicidal, or undetermined. These three concepts should not be confused. Consider an unusual example. Suppose a person dies after falling from the balcony of a high-rise building. The immediate cause might be multiple traumatic injuries. The mechanism could involve severe internal bleeding and traumatic shock, but the manner of death remains a separate investigative question. Was the person accidentally leaning over the balcony? Did they intentionally jump? Were they pushed? Or was the body placed there after death? The injuries alone may not answer all these questions. That is precisely where forensic investigation becomes essential. The first principle to understand is that a death scene can be misleading. A scene may appear to suggest suicide but actually represent homicide. A death may initially look accidental but later evidence may indicate intentional involvement. Conversely, suspicious circumstances may ultimately be explained by an entirely accidental sequence of events. Forensic science therefore attempts to reduce dependence on assumptions and instead build conclusions from objective evidence. Consider a hypothetical case involving a person found dead beside an electric scooter on a deserted road. The initial assumption might be a road traffic accident, but forensic examination reveals something unusual. The injuries on the body do not correspond with the position in which the body was found. The scooter has minimal damage, and microscopic examination reveals fibers on the victim's clothing that are inconsistent on the road surface. Suddenly, the question changes. It is no longer simply, was this a traffic accident? The investigator must ask, was the scene staged? This illustrates one of the most important principles of forensic investigation. The scene must be interpreted through evidence rather than through the first apparent explanation. The forensic investigator acts as a scientific link between the scene and the investigative process. The investigator documents the scene, identifies potential evidence, determines what should be collected, preserves it appropriately, examines relevant physical and biological materials, and interprets the findings within the circumstances of the case. However, forensic investigators do not work in isolation. A death investigation usually involves several professionals. Police officers secure and investigate the scene. Forensic scientists examine physical evidence. Medical professionals conduct the post-mortem examination. Toxicologists analyze biological samples for drugs, alcohol, poisons, and other substances. DNA specialists may examine biological material. Digital forensic experts may examine electronic devices. Ballistic experts may examine firearms and ammunition-related evidence when relevant. The final reconstruction emerges from the integration of these different forms of evidence. This is an important point. Forensic science is rarely about finding one magical piece of evidence. Instead, it is about determining whether multiple independent findings support the same reconstruction. The investigation begins with the scene. The first priority is scene security and preservation. Unnecessary movement of objects, contamination, introduction of foreign material, or careless handling of the body can compromise evidence. Before anything is moved, the scene should be documented. This includes overall photographs showing the relationship between major objects, mid-range photographs showing individual items in relation to the surroundings, and close-up photographs documenting specific evidence. The investigator may also prepare sketches, measurements, notes, and increasingly three-dimensional or digital documentation of the scene. But documentation is not simply about taking attractive photographs. The objective is to preserve the original spatial relationship. Imagine a body found near a staircase. A photograph showing only the body may tell us very little, but a properly documented scene may show the exact relationship between the body, the staircase, a broken railing, footwear impression, bloodstains, scattered objects, and nearby furniture. That spatial information can later become crucial during reconstruction. An important forensic principle is that body itself must be treated as evidence. Investigators examine the position and condition of the body, clothing, visible injuries, signs of disturbance, biological material, and other relevant findings, but the examination should be systematic. For example, clothing may contain fibers, hairs, soil, glass fragments, plant, biological stains, or other trace materials. Suppose a victim is found in an apparently isolated location. Their clothing contains tiny fragments of a particular type of industrial paint. That discovery may appear insignificant at first, but if the victim had no occupational or environmental reason to come into contact with that paint, investigators may begin examining vehicles, machinery, buildings, or other locations associated with the case. This is the power of trace evidence. A tiny particle can sometimes establish a connection between a person, object, and location. Now let us discuss evidence examination in greater detail. Evidence in an unnatural death investigation can broadly include biological evidence, trace evidence, impression evidence, physical evidence, chemical evidence, toxicological evidence, and digital evidence. Biological evidence may include blood, saliva, semen, hair with suitable biological material, tissue, or other cellular material. Such evidence may be examined using serological methods and DNA analysis. DNA evidence can be particularly useful in determining identity or association. However, an important forensic principle is that finding someone's DNA does not automatically prove that the person has committed a crime. DNA must be interpreted within its context. For example, if DNA from another individual is found on an object in a victim's home, investigators must ask how and when that DNA could have been deposited. Was the person recently present? Was the object commonly handled? Could the DNA represent secondary transfer? Was the material deposited before or after the relevant event? Therefore, forensic investigation requires context. Trace evidence can be especially valuable when there is no obvious weapon or direct evidence. Consider a case where a person is found unconscious in an abandoned warehouse and later dies. There are no obvious wounds. Investigators initially suspect poisoning or exposure to a toxic substance. During scene examination, however, small fragments of synthetic polymer are recovered from the victim's clothing. Laboratory comparison indicates that the material is consistent with the specialized industrial protective coating used in the particular type of machinery. The material does not prove homicide, but it provides an investigative lead. Forensic science often works exactly this way. A small observation often changes the direction of an investigation. Bloodstain examination may also contribute to reconstructing events. The investigator may study the size, shape, distribution, and location of bloodstains, along with the relationship between stains and surrounding objects. For example, a bloodstain pattern on a vertical wall may provide information about the direction of blood movement. However, interpretation must be cautious because bloodstain patterns can be affected by many variables. The important UGC NET concept here is that bloodstain pattern analysis is not simply about looking at a stain and announcing what happened. It involves systematic examination of physical characteristics and interpretation in relation to the scene. Footwear impressions, tire marks, tool marks, fingerprints, and other pattern evidence may also assist the investigation. Suppose investigators find a deceased person inside a closed workshop. There are no usable fingerprints on the obvious entry points. However, a partial footwear impression is found in a layer of fine dust near a rare entrance. The impression can potentially provide information regarding the type or characteristics of footwear and may help investigators compare it with footwear associated with the suspect or other relevant person. Again, it is important to distinguish association from identification. Evidence may establish that an object is consistent with another object or that a person could have interacted with the particular scene. The strength of that association depends on the quality and uniqueness of the evidence. Toxicology is particularly important in unnatural deaths where poisoning or drug exposure is suspected. In many cases, the external examination of a body may reveal very little. A person may appear to have died suddenly without obvious external injury. Toxicological analysis may therefore become essential. Samples such as blood, urine, gastric contents, liver, or other tissues, depending on the circumstances, may be collected for laboratory analysis. The toxicologist does not simply ask, is a chemical present? The more important questions include what substance is present, at what concentration, how was it introduced, is the concentration significant, could the substance have contributed to death? Are there therapeutic or environmental explanations? This distinction is extremely important because detecting a substance in the body does not automatically establish that it caused death. For example, a medication may be detected because it was prescribed to the deceased. Its mere presence is not proof of poisoning. The forensic interpretation must consider concentration, toxicological significance, medical history, circumstances, and other autopsy findings. The post-mortem examination is one of the central components of unnatural death investigation. The forensic pathologist examines the body systematically, documenting external injuries, internal injuries, pathological findings, and other relevant features. The examinations may help determine the cause of death and provide evidence relevant to the manner of death. One fascinating aspect of forensic pathology is that injuries can sometimes tell a story about sequence. Suppose a person has multiple injuries, the investigator must determine which injuries were potentially fatal, which may have occurred earlier, and whether some injuries could have resulted from attempts to defend oneself or from subsequent movement. But the pathologist must also recognize that not every injury is directly related to the cause of death. For example, superficial abrasions may result from contact with a rough surface after death or during movement of the body. Therefore, injuries must be interpreted alongside scene findings and other findings. Another major investigative question is the estimation of the post-mortem interval or the approximate time that has passed since death. Investigators may consider findings such as body cooling, rigor mortis, liver mortis, decomposition, ocular changes, and other biological processes. However, these findings are influenced by environmental and individual factors. Temperature, humidity, clothing, body size, environmental exposure, illness, and many other factors can influence post-mortem changes. Therefore, the time since death should generally be expressed as an estimate rather than an unnecessarily precise number. Forensic science is powerful, but it is not magic. A scientifically responsible investigator recognizes uncertainty. One of the most important principles in unnatural death investigation is the comparison between the condition of the body and the condition of the scene. Let us imagine a person found dead in a bathroom. The scene appears to suggest a fall. There is a damaged mirror, water on the floor, and an injury to the head. But during examination, the forensic pathologist identifies injuries that are difficult to explain by the apparent fall alone. Investigators then examine the bathroom carefully. The distribution of broken glass, the location of bloodstains, and the position of objects do not correspond with the proposed sequence. At this stage, the initial explanation becomes questionable. This is why forensic investigation must be approached as a reconstruction problem. The investigator is essentially asking, if the proposed event really occurred, what evidence should I expect to find? Then the investigator compares that expectation with what is actually present. This is one of the most powerful ways of thinking about forensic evidence. An important and interesting issue in unnatural death investigation is the possibility of a staged scene. A staged scene is one in which the apparent circumstances have been deliberately altered to create a misleading interpretation. For example, an actual homicide may be made to appear like a suicide, or an accidental death may be presented in a manner intended to conceal another event. Investigators therefore look for inconsistency. Does the injury pattern correspond to the proposed mechanism? Does the physical evidence support the claimed sequence? Are there unexplained biological stains? Are objects positioned naturally? Does the condition of the clothing correspond with the alleged event? Are there signs that the body was moved? Do digital records contradict the proposed timeline? These questions can expose discrepancies that are not immediately visible. Modern forensic investigation cannot ignore digital evidence. Today, a person's final hours may leave behind an extensive digital trail. Mobile phones, smartwatches, navigation systems, access control systems, surveillance cameras, messaging applications, online transactions, and cloud-based records can provide valuable chronological information. Imagine a person is reported to have died at home at approximately 10 p.m. However, digital evidence shows that the person's phone connected to a cellular network several kilometers away at 9:40 p.m. A vehicle tracking system recorded movement at 9:50 p.m. and a smartphone device recorded the opening of the front door shortly afterward. These findings do not automatically prove what happened, but they may challenge the original timeline. This is why modern forensic investigation increasingly combines traditional physical evidence with digital reconstruction. Now let us bring all of this together and understand the overall investigative process. The process generally begins with the discovery or reporting of the death. The first responders secure the area and assess whether there is an immediate danger or possibility of life-saving intervention. The scene is then protected from unnecessary access and contamination. Investigators conduct a preliminary assessment and document the scene before the evidence is disturbed. Photographs, videos, sketches, measurements, notes, and other forms of documentation are prepared. The body and surrounding environment are examined systematically. Potential evidence is identified and collected using appropriate method. Each item must be properly packaged, labeled, sealed, documented, and maintained through the chain of custody. Chain of custody is an essential concept for forensic science examination. It provides a documented history of who collected the evidence, who handled it, when it was transferred, and where it was stored. Why is this important? Because evidence is valuable only when its integrity can be demonstrated. Imagine that a crucial biological sample is recovered from a scene. If there is no reliable documentation showing where it came from, who handled it, and how it was preserved, questions may arise regarding contamination, substitution, or improper handling. Therefore, chain of custody protects both the evidence and the credibility of the investigation. After collection, evidence may be sent to appropriate forensic laboratories. Different evidence requires different specialists. Biological material may undergo DNA analysis. Unknown substances may undergo chemical analysis. Blood or other biological samples may be examined toxicologically. Fibers, glass, paint, soil, and other trace materials may undergo comparative examination. Firearms related evidence may be examined through forensic ballistics when applicable. Digital devices may be examined by digital forensic specialists. The laboratory findings are then interpreted alongside the scene and medical findings. The ultimate objective is not simply to produce a collection of laboratory reports. The objective here is reconstruction. Investigators attempt to construct the most scientifically supported explanation of the events leading to death. Let us imagine a case involving a person found dead in a rented studio. There is a damaged window, a broken ceramic cup, a small bloodstain on the floor, and a mobile phone lying several meters away. At first, the scene appears chaotic. Laboratory examination reveals that the blood belongs to the deceased. Fingerprint examination identifies prints on the cup. Footwear impressions indicate movement across the room. Digital examination reveals that the phone was active shortly before the estimated time of death. Autopsy findings identify injuries that correspond with some but not all of the apparent events. Not single finding solves the case, but when the findings are placed on a timeline, the investigator can begin asking which sequence of events is physically possible. This is the essence of forensic reconstruction. A very important principle in forensic investigation is avoiding premature conclusions or tunnel vision. If investigators decide too early that a death was suicide, they may unintentionally interpret later evidence through that assumption. Similarly, if they decide immediately that a death was homicide, they may overlook evidence supporting an accidental explanation. A good forensic investigation should therefore remain open to competing hypotheses. The investigator should ask what evidence supports this explanation, what evidence contradicts it, what alternative explanation could account for the same findings. This scientific mindset is particularly important in cases where the initial circumstances are ambiguous. The strongest forensic conclusions often emerge when multiple independent findings point toward the same explanation. Imagine that a suspected staged accident produces three independent findings. First, the injury pattern is inconsistent with the claimed accident. Second, the physical evidence at the scene indicates that the body may have been moved. Third, digital evidence places another individual at the location during a relevant period. Individually, each finding may have alternative explanations. Together, however, they may significantly alter the probability of the proposed scenario. This illustrates an important principle. Forensic science should be interpreted collectively rather than in isolation. Before we conclude, let us revise one of the most important examination concepts. Remember, cause of death tells us what produced the death. Mechanism of death tells us the physiological processes through which death occurred. Manner of death tells us the circumstances or classifications surrounding the death. For example, suppose an individual dies following a severe traumatic injury. The injury may represent the cause. Massive blood loss may represent the mechanism. The manner could potentially be accidental, suicidal, or homicidal depending on the circumstances and evidence. Therefore, one should never assume that identifying the injury automatically establishes the manner of death. Forensic investigation of unnatural deaths is essentially an exercise in scientific reconstruction. The body provides evidence, the scene provides evidence, clothing provides evidence, biological material provides evidence, trace evidence provides evidence, toxicology provides evidence, digital devices provide evidence, and sometimes even the absence of expected evidence can become significant. The forensic investigator's task is to bring these different pieces together without allowing assumptions to replace scientific reasoning. A suspicious death may begin with a simple question, "What happened here?" But forensic investigation transforms that question into a structured sequence. What happened? Where did it happen? When did it happen? How did it happen? What caused death? What was the physiological mechanism? Was the scene authentic? What evidence supports the proposed sequence? What evidence contradicts it? And finally, what conclusion is best supported by the totality of the evidence? That is the real strength of forensic science. It does not simply look at the death, it reconstructs the events surrounding death through scientifically examined evidence. Understanding this sequence will help you connects several forensic disciplines rather than just memorizing facts. In the next lecture, we will continue exploring the forensic investigation process and examine how specific forms of evidence can help investigators distinguish between accidental, suicidal, homicidal, and other forms of unnatural death. Thank you for watching and keep learning forensic science not just as a collection of facts but as the science of reconstructing what happened when the evidence is all that remains. Don't forget to like, share, and subscribe.